Hi friends, so we're going to take a look at using the ratio test with a couple of recursive series. So recursive series means that, so like here the first term is defined and then the next term is defined in terms of the previous term. So these are recursive series, and so for both of them we're going to use the ratio test. So I'm just going to jump right into it and talk about this. Okay, so the whole thing with the ratio test is that we want to compute a sub n plus 1 over a sub n, and then after we compute this, we want to eventually take the limit as n goes to infinity. Okay, so here's what's like weird about this. What is a sub n plus 1? It is this, and then a sub n we can honestly just leave as a sub n. So what's weird about like setting up these recursive series is it almost feels like cheating. So here's my setup. So it doesn't even matter, right, what a sub n is, because like ultimately like it's going to end up canceling out because the next term uses a sub n. And that's kind of like the beauty and the whole point then of like doing the ratio test with a recursive series. So then I just have to figure out what is the limit as n approaches infinity of 1 plus cosine n over n. And so I can break this into two pieces then. So this will be 1 over n and then cosine n over n. So this is just going to go to 0. And then this will also end up going to 0 by the squeeze theorem. In that negative 1 is less than cosine n, which is less than 1. So if I divide all of those by 1, this goes to 0, this goes to 0, therefore this is going to go to 0 as n goes to infinity. So this just equals 0. And since this is a number less than 1, what that means then is that this recursive series converges absolutely. Okay, so now let's compare that to the next example. So it's the same idea of a setup here. So I'd strongly recommend, if you are watching this because you weren't sure how to approach this, that maybe you try this on your own before you watch the explanation. That'll just help you get more out of the video. All right, so I'm going to set this up again. Same idea. So I've got this nth root of n over 2 times a sub n, all of this over a sub n. And so once again, the a sub n's are going to drop out, so I can just go ahead and take the limit as n approaches infinity of the nth root of n over 2. Now, the limit of this nth root of n, this is actually one of the common limits. So when I teach this course, so I talk about a list of common limits. So this is just like one thing that we just like know. You could also use like L'Hopital's rule to eventually get you there, but in this case, I'm just going to say this is a common limit. So I know that this limit is just going to come out to 1 over 2. That is also less than 1. So that means that this series also converges absolutely. Okay, and so that brings us to the end of those examples. So if you found that helpful, please consider hitting the like button, and I will catch you guys next time. Thanks for watching.